Hey everybody, hope your first lesson went okay for you. So this is round two, day number two of redox, and we're just going to keep working on those half reactions and net reactions. They're going to be a little more complicated today. So yesterday I started off with a song by Megadeth, Return to Hangar, and it had a line in it about oxidation. So today I thought I'd go with reduction. And so I Googled and found a few songs that have reduction in the band name. I got to tell you, this stuff's pretty intense. So the first one is a reduction by Kings Often Run. Here we go. Okay, that was a little out there for my comfort zone of music. And the second one I found was Harlot Systematic Reduction. Those are pretty intense, actually. I'm not sure that that's my style of music. Anyway, hopefully you enjoy that, and we're going to dig into our lesson today. So on the first screen here is just a little bit of a review to get you back up to speed. So critical, and I went through this yesterday, you need to remember Ralio and you need to remember Ogre. So Ralio is the reducing agent, and you can see here that it is losing an electron and undergoing oxidation, or we can say the reducing agent loses electrons oxidized. And on the other side, the oxidizing agent, Ogre, so the oxidizing agent gains electrons and undergoes reduction, or we can say the oxidizing agent gains electrons reduced. Some people say reduced in charge because it is becoming more negative. And if we look at this overall reaction, we can split it into its two half reactions. How does zinc go from an element with a charge of 0 to zinc with a charge of 2 plus? To become more positive, you have to lose negative. So if you lose electrons, you are Ralio, the reducing agent, losing electrons and undergoing oxidation. Copper goes from a charge of 2 plus to an element with a charge of 0. So how do you get from 2 plus to 0? You have to add or gain 2 electrons. If you gain, then you are the oxidizing agent gaining electrons reduction. And this is a redox reaction, reduction and oxidation. Okay, a little more review. So now I have some half reactions. Remember that a half reaction always shows the electrons. So the questions are, for each of these reactions or half reactions, is it oxidation or reduction? So for the first one, we can use oil rig to help us out. Oxidation is a loss, reduction is a gain. So the electrons are on the reactant side. Think of it as energy. If it was energy sitting on the reactant side, would this be endothermic or exothermic? Gaining or losing energy? And the correct answer is gaining. So this is rig, G for gain. It's a reduction is a gain. So this half reaction is reduction. This silver is gaining. And it's a half reaction. We've already talked about that. And is it an oxidizing agent or a reducing agent? And who is it? So it's always the reactant we're interested in. So if it is gaining, then we use the G, Ogre, G for gain. So it is an oxidizing agent gaining electrons and undergoing reduction. And who is it? Ag plus. Okay, I'm going to pause the video, and you're going to pause the video and try this one on your own. And then if you've got some courage, try this one on your own and then unpause and see how you did. Okay, so first reaction. We've got electrons on the product side, so that means that it is a loss. So we're using the L reactions, oil for loss and Ralio for loss. Okay, so first question, it is oxidation or reduction. Oxidation is a loss. Okay, second question, half reaction or net. And it is a half reaction because we have electrons. We can see the electrons and it's only one species, it's half. And who is our oxidizing or reducing agent? So we're looking for the reducing agent that lost electrons. The two chlorides are the reducing agent. This one's a little trickier. We got to split it into its two parts. So we have two NAs going to 2Na plus, and we have F2 going to 2F minus. So is this oxidation or reduction or both? Well, let's see. Where do the electrons go? Always to the more positive side. 0, 2 plus, 2 minus. 0, 2 minus, 2 minus. So now we've got our balanced half reactions. So this one is both oxidation and reduction. This half reaction, it is a loss, L. Oxidation is a loss. And reduction is a gain of electrons. Okay, half reaction or net. So this is the net reaction made up of both halves. And our oxidizing agent is the G reaction, Oger. Whoever's gaining is the oxidizing agent, so that would be fluorine. And our reducing agent would be the other reactant, the two sodiums that are losing. Reducing agent loses electrons, Ralio. So again, we are using those sayings to understand and explain what's going on in the half reactions and classifying the chemicals. Okay, that was your review. Now we're going to launch into let's skip this one. Yeah, we're going to skip it. Let's launch into today's lesson. Okay, complex half reactions. So we just finished simple half reactions that have either a metal or a non-metal, an element or an ion. Complex half reactions have polyatomic ions and molecular compounds. So these are a little more complicated. They've got more than one element in the species. So because they have more than one, we have to use additional molecules to help us out. Water and hydrogen ions are the two additional species that we're going to be using. Hydroxide is enrichment, so we're not going to do that one. Water and hydrogen. Okay, I'm just going to go through the method and then you'll see how it works as we use it. Okay, it's called the 5-step method. I wonder why they call it 5 steps. Okay, so step number 1, write the chemical formulas for the reactants and the products. There it is. So I'm just going to write it down here with some space. NO3 minus, aqueous, goes to N2O4, gas. Okay, balance all atoms other than oxygen and hydrogen. So that's, in this case, refers to the nitrogens. So I have 2 nitrogens, 2 nitrogens. So it's like I'm balancing a chemical equation. Okay, so nitrogens are balanced. Now I can look at my oxygens, balancing those, and then hydrogens. So we're done step 1 and 2. Step 3, balance the oxygens by adding water. So these reactions are always aqueous. We can freely add water to either reactants or products. So how many oxygens? 2 times 3 is 6 oxygens, and here I have 4. So I need 2 more on this side, and I do that by adding 2 waters to give me my 2 more oxygen. So now I have 6 oxygen and 6 oxygen, okay? And that's water liquid. Good. Now waters are balanced, or oxygens are balanced. Now the hydrogens by adding H+. So I'm going to add, let's see, what have I got? 4 hydrogens here. No more there, and none here. So I need 4 hydrogens on this side. And these reactions are always acidic. And because they're acidic, that means H+ is present. So we can add H+ to either side. So I'm free to add H+ to the reactant side, aqueous. Okay, now I've got 4 hydrogens, 4 hydrogens. They're not atoms or ions or molecules. They can be any of those 3. So we balance the hydrogens, we balance the oxygens, we balance the nitrogens. This is a balanced equation except for the electrons. and it is a complex half reaction, so we need to put electrons in it, and you do that by balancing the charge with electrons. So we have to look at the overall charge on both sides. So I'm going to do a little chart here with a plus minus. So on the left side, we've got 0 in this molecule and 4 positives. So plus 4. 0 in this molecule and 0 in this molecule, 0 on the right. Plus 4 on the left, 0 on the right. So we're going to add electrons. And remember, you always add electrons to the more positive side. In this case, the left is more positive. So I need to add 4 electrons or 4 minuses to get to a charge of 0. So 4 electrons, and that is a balanced complex half reaction. They don't really get much harder than that. So if you've got that process down, great. We'll try another one. If you don't, look it over again, maybe cover over this reaction, write it out and try it again. I guess my apologies. I forgot to tell you that we are on page 192 in your study guide. Hopefully you figured that out on your own. Okay. Next one, MnO4 minus to Mn2 plus. Let's keep the rules there. Okay, so if you want to try this on your own, you can pause the video here. If you just want to follow along with me, that's fine too. Okay, so there's our unbalanced half reaction. Sometimes they call that a skeleton equation or a skeleton reaction. It's just the bare bones. Now we're going to add the meat. Okay, balance all atoms other than oxygen and hydrogen. 1 manganese, 1 manganese. So they're balanced. So now we go after oxygens first by adding water. 4 oxygens, 4 waters. Okay, so now we got our 4 oxygens. Now I've just introduced 8 hydrogens, and there's no other hydrogens, so I need 8 hydrogens on the opposite side. They're aqueous hydrogen ions. Okay, everything's balanced. 1 manganese, 1 manganese. 4 oxygen, 4 oxygen. 8 hydrogen, 8 hydrogen. Now all we have to do is add electrons to the more positive side. I'm going to use a little chart to help me out here. Plus minus. I've got plus 8, minus 1. Don't forget about that. Plus 2 and 0 for the water. So we're at plus 7 plus 2. Add the electrons to the more positive side. That's this one. And we need 5 negative electrons, or 5 minus, to get us to 2 plus, and then they're equal. Okay, 5 electrons. And that is a balanced complex half reaction. Okay. Whoops. One more. So pause the video. I'd like everybody to try this one on their own and then come back and check to see how you did. All right. So here we go. I'm going to do this one fast. So nitrogen, 1 nitrogen, 1 nitrogen, 2 oxygen, 1 oxygen, 2 oxygen, 2 hydrogen, 1 hydrogen. So we need to add 1 more. Okay, 2 hydrogen, 2 hydrogen, 2 oxygen, 2 oxygen, 1 nitrogen, 1 nitrogen. Charge of 0 on this side, charge of plus 1 on this side. So I need 1 more electron. 1 electron, so 1 minus to give us a total of 0, which equals 0 on the other side. Balanced. Balancing in basic solutions is enrichment. We don't have to worry about it. And because we're just getting through the essentials with online learning, gonzo. Hopefully that makes lots of you happy. One less thing to worry about. Okay, so all we have left to do now is balance a complex net reaction using our half reaction method. So all we're going to do here is rip these apart into their 2 half reactions, balance the half reactions, and then add them up to get a net reaction, making sure that the electrons are equal on both sides. So it's just a couple extra steps, but it's not that difficult. So here we go. I'll lead you through the first one. And this one is in your notes, page 193. Okay, here we go. OF2 goes to F minus. There's our first half reaction. It's the fluorine we're interested in. Oxygen is always taken care of with water, so we're never worried about that. Okay, second half reaction, I minus goes to I3, 1 minus. Very unusual ion. All right, let's do the top reaction first. So if you want to pause the video and try and balance these on your own, the two half reactions, you could do that and then check to see how you did or follow along with me. Okay, balance all atoms first, other than oxygen and hydrogen. 2 fluorine, 2 fluorine. Okay, fluorines are done. 1 oxygen, 1 water gives me 1 oxygen. 2 hydrogen, 2 hydrogen. Okay. All right, charges are a little tricky on this one. I've got +2 and -2. So a lot of students would try and add 2 electrons to balance it out, but that's not right. I'm at +2 and -2. I have to get them the same, so I'm going to add to the more positive side, and I need to add -4 to get the two sides the same. So 4 electrons get added. Okay, second reaction, balance all atoms other than oxygen and hydrogen, 3 and 3. We don't need to add any waters or hydrogen because this one's done other than charges. So we have 3 minus and 1 minus. Add to the more positive side. 2 more minuses gives me 3 minus to go with the 3 minus. So we're done. Okay. Last step. Before we can add these two reactions together, electrons gained must equal electrons lost. We are gaining 4 and only losing 2. So we've got to multiply the entire bottom equation by 2 so that we can get 4 electrons. So 3 times 2 is 6. 2 times 1 is 2. 2 times 2 is 4. Okay, 4 gained, 4 lost. We can cancel them out. And then we just add everything else together. This is sort of like Hess's law in enthalpy when you're adding individual reactions together. Whatever's on the left side or the reactant side just carries down. And there it is, balanced complex redox reaction. You don't see the electrons behind the scenes, but you do know that 4 were gained, 4 were lost. You can answer all kinds of questions because this is gain. This is our oxidizing agent gaining electrons undergoing reduction. This is a loss, so this is our reducing agent losing electrons and undergoing oxidation. Okay. We got 2 left and then we're done today's lesson. That's great. These ones I chose more challenging ones just so that when you try these on your own, you'll have done the toughies and then you're not so intimidated by these guys. All right, so first one, separate it into its half reactions. If you want to pause the video and do that, you can. If you want to try the whole thing on pause and then come back and see how you did. All right, so there's my 2 half reactions, skeleton half reactions. Now I'm going to put some meat on their bones. 1 manganese, 1 manganese, 4 oxygen, 2 oxygen, add 2 more oxygens with 2 waters. Now hydrogens, I've got 4 here, none anywhere else, so I need 4 more. I'll sneak them in there. 4H plus. Okay, charges. I'm going to do a little T-chart here for the left and right. So I've got -1 there and +4. And on the product side, they're all neutral, 0. So I am at +3, and I need to add the electrons to the more positive side. So I get -3. 3 electrons on the reactant side takes me to 0. Okay, good. First one done. Second reaction, balance all atoms other than oxygen and hydrogen. 2 carbon, 2 carbon. 4 oxygen, 4 oxygen. Whoa, that one's done. Interesting. Okay. No hydrogens needed. I just have to balance my charges. I've got a 2 minus, and this is a molecule, so 0. So the right side is 0, and the left side is 2 minus. So I need to add 2 minus to the right side. 2 electrons. Okay, so those weren't too bad. Here's the tricky part to this one. I've got 3 electrons gained and 2 lost. So I am going to need to get a common multiple for the electrons, and that would be 6. So that means in the top reaction, everything gets multiplied by 2 to get 6 electrons, and in the bottom reaction, everything gets multiplied by 3. So I'm going to write all of this out, and then we'll see what cancels out here. So I've got 6 electrons in the top, 2 MnO4 minus, 8 H plus, 3 C2O4 2 minus. Okay, there's all my reactants. 6 CO2s, 6 electrons, timesing everything in the top by 2, MnO2, 2 of those, and 4 waters. Okay, it looks like the only things that cancel out are the 6 electrons. Yeah, that's it. That is my balanced half reaction. So we got 8 and 2 and 3 and 6 and 2 and 4. Good. Okay. I would put that one as like a 4 out of 5 for difficulty. It's a lot going on there. Okay. Now we're going to go to a really challenging one. If you are feeling like you're rocking it, you can try this one on your own. And, well, I suggest you pause and try it on your own. If you get into trouble, whatever, fix it up after you see the solution. So go ahead and pause and try this last one on your own, and then come back to see how you did. All right, I'm going to build my skeleton half reactions. Just going to skip states for now. Everything's going to be aqueous. All right, let's do that first one. 2 carbon, 1, 2 carbon. Carbons are done. Oxygens, 1, 2. So I need 1 water to balance the oxygens. Now I have 5, 6, 8 hydrogen, and 3, 4. Okay, there's my 4 more hydrogens. So all of the elements are balanced. Now electrons, 0, 0, 0, 4 plus. So this one's easy. 4 minus. Okay, first reaction done. Now this one's tricky. 2 chromium, 2 chromium. 7 oxygen, 7 oxygen. 14 hydrogen, 14 hydrogen. Okay, what's left? Everything's done except the charges, and this one is tricky, so I'm going to do a little chart for the left and the right. Plus 14, minus 2, so we're at plus 12. This gets everybody. 2 times 3 is 6 plus, so we're at 6 plus and 12 plus. So what do I do? 6 negatives to the more positive side to give us 6 plus, and then they're balanced. 6 minus. There we go. By the way, if you ever get one of these reactions and you're getting both the electrons on the same side, they're both on the reactant side or they're both on the product side, you did something wrong. You got to start over. You always will have a loss and a gain. Okay, those are pretty tricky. And now to make it even more challenging, the lowest common multiple of 4 and 6 is 12. So we got a choice here. We can just multiply right through the reactions or rewrite them out. That one's times by 3. and this one is times by 2. I think, what am I going to do here? I have nobody to ask. I think I'm going to rewrite them just because they're pretty complex. So 3H2O plus 3C2H5OH goes to 3CH3COOH, 12H plus, and 12E minus. Okay, second reaction, 12E minus, 28H plus, 2 CR2O7 2 minus goes to 4 CR3 plus and 14 waters. Holy smokes. Okay, now we can cancel out 12 electrons, 12 electrons. So in this reaction, we have 3 water on the left and 14 on the right. So we can take away 3 from both. 3 is gone. 14 becomes 11. Okay, anything else? H pluses, 28 and 12. So we can take away 12 from both, which leaves 16. And I think that's it. So 16 H pluses, 3 C2H5OH, 2 dichromates, 4 CR3 plus, 11 waters, and 3 CH3COOH. Now I can go back and put my states in to clean it up. Liquid and aqueous. That one is a beast. That's quite challenging. Okay, so this is a key skill. We're going to be balancing redox reactions through this entire chapter and chapter 14 as well. So this is like the fundamental skill that you need to have down as we move through. So you will have to spend some time on this. Balancing redox reactions equations in your study guide, page 238. Answers are in the Google Classroom for that one. Page 240 and 241. I'm not sure if I'm going to be taking that one in. That's a question mark. You'll definitely want to do it. I may post answers online. I'll let you know on Wednesday what I'm going to do with that assignment. Okay. Definitely you want to do all those pages and be checking to see if you are getting these right. They are challenging. Okay. And that is it. So I say to you, peace out, small fries. Catch you on the flip side.